Okay, let's get started. Hello and welcome. My name is Bernie Pruss, and you're in Maximizing Productivity in Snowflake, building scalable data platforms efficiently. So I've been working in databases for 30 years, now in data warehousing over 25. I specialize in business intelligence and data analytics platforms. I found Snowflake about 6 years ago and realized that after 20 years at that point of building warehouses, that I did not want to build warehouses on any other platform until somebody actually gets better than Snowflake. I've worked on many platforms over the years, Oracle, SQL Server, and many others. One of the things that I have a degree in engineering, and so one of the things that was always missing until the last 5 years or so was just basic software engineering processes in the data warehouse space. I also hold the Snowflake Advanced Architecture certification, and my company, Cloud Data Consulting, is a services partner with Snowflake. This is the first session of a series that we're setting up called the AI Ready Data Stack. And let me just do a couple of little bullets here, right? We're all, well, many of us, if not all of us, are starting to use AI now. Since ChatGPT came out, it's been crazy how much work we can get done. I have been using Claude Code to rewrite some of our Terraform code, which is really cool. The message that I get from all the people that I work with who are really out there thinking a lot about AI and being able to use it is that those who learn to use it will outperform those who do not. Or, yeah. The other big thing that I see everywhere is that if you feed AI bad data, you're going to not get the best results. The other thing that I think is really important to think about is that your AI strategy is going to depend on your data strategy. So if you don't have a data strategy or you haven't thought about your data strategy very much, it's going to be hard to really implement a good data AI strategy. All right, let's see here. I'm hitting the space bar and it's not going to the next. Oh, there we go. So being productive in a data warehouse environment and a data environment, it's a challenge. For many years, data platforms took too long to build. Many of them never made it to completion, never got an ROI, or they would take years and years to get done. Today, we're going much faster. But still, even with all of the good tools that we use today, if we're not careful, technical debt can accumulate quickly. If we take a shortcut, if we don't do our due diligence and documentation, it will build up fast. The other issue is that people leave, people rotate through, people retire. And when that happens, if you haven't been capturing your knowledge as you go, you're going to lose out on that knowledge and then it will be expensive. The other thing we've learned is manual processes don't scale. Once Terraform has been a game changer for us, we used to go in and click to build things in sometimes in Snowflake, sometimes in AWS or Azure. And now that we're using Terraform everywhere and other automated processes, it just makes a huge difference. The other thing is that everyone is busy. A lot of times when we're building a data warehouse, we need to interact with other parts of the business. They're all busy. We want to maximize our productivity when working with them. And that's also very important. All right. So here's a thing called a little bullet called the productivity flywheel. If we automate our infrastructure, that leaves more time for data. The first few Snowflake warehouses I built, we probably spent 2 months getting everything set up in Snowflake because we were doing it manually. It was the first time. Over the years, we developed a product of sorts we call our Snowflake Jumpstart, and now we can build everything in Snowflake let me say it this way. We have an opinionated architecture. If you agree with our opinions, we can start it in one day, have everything up and running. If you don't agree with our opinions, it might take a few days or a week to restructure to match your opinions. Another thing that's really important is we need to document continuously. We want to test everything. If you're not testing, things will get into production that will break. We have proven tools that work really well, and it never ceases to amaze me when a data team will decide they don't want to use any tools and they're going to program everything themselves. I'm sure they have good arguments for that, but that philosophy eludes me. We need to be able to share our knowledge and have a knowledge repository so that when we get new people, when we start a new subject area, that we can scale quickly. All right. Next section is the foundation is going to be infrastructure as code. We like Terraform. You could use other tools. Every cloud platform has their own infrastructure as code language. But the reason we like Terraform is because Snowflake runs on all the different the three major platforms, Amazon, Azure, and GCP. Terraform can be used on tons of infrastructure, not just these four things, Snowflake, Azure, AWS, and GCP, but at least we're using one infrastructure tool and not one for every system. All right. There's what we call a blank slate problem. Whenever we get Snowflake, a new account in Snowflake, it's empty. There's a lot of words here, but I'll just touch on them really quick. It's empty. It's a blank canvas. It offers us full flexibility, but we need to make some decisions and we need to organize it and we need to maintain it after we get started. So we use infrastructure as code, and we have several key considerations, which I am going to cover. And I see I dropped a one in the middle of my security there. Good job, Bernie. But these I'll just knock through really fast because I'm going to go through them on the next slides. So security, role-based access control, least privilege principle, data governance, future-based grants, these are all critical. And getting these set up right and maintaining them manually would be really difficult. The other thing we need to think about is how are we going to organize our data warehouse environment? We believe in standard database structures, naming conventions, role hierarchies, and managing all of that over time without some automation and without some software engineering practices is you'll just get to a point where people will get lost, people will just lose productivity. So efficiency is also very important. We don't want to waste time. So one of the big things we manage right away is setting up the warehouses. If you're new to Snowflake, a warehouse is what Snowflake calls its compute cluster. So setting them up and tuning them, we do that in advance for the most part, because one thing I didn't mention is we've so far built 19 Snowflake data warehouses for our customers. And those are the ones that went to production. We built dozens that, in development and practicing setting things up, but those are 19 that went to production. With a warehouse, we want them to auto start and auto stop, which is amazing for efficiency and for cost control. So one of the things, there are some other competing tools out there, which I won't name today, but who take 15 to 20 minutes to start up. And actually, I think they've come out with a product that tries to auto start, auto stop. But if it takes a long time to start, you're going to have to leave it run. That costs more money. We want to use the right size to be efficient. We want to auto scale. That's really powerful. Future price grants are amazing. They allow us to set up in advance all of the grants that our tools are going to need, so that when one of our ETL tools creates a new table, the grants get created automatically. We want stability and maintainability, and we want to make sure our environments are easy to grow, to replicate, and to manage over time. Namespace and data flow. Let's talk about that for a minute. I have some diagrams coming in a second, but just to cover the basic ideas, we load our data from source systems into a raw layer of databases. We give every tool its own raw database, and that data should mirror the source systems. This follows a new, and it's not even that new. In 2006, Oracle put out a white paper on ELT versus ETL. And I started realizing and learning over the years that extract, then load, then transform is really way better than the old style of extract, transform, and then load. So that we can have multiple raw databases. Those are going to load what we name the app EDW DB, EDW standing for Enterprise Data Warehouse. And that's where the transformed data goes that the BI tools are going to read. Once we get into the EDW, we separate the data into stage, intermediate, and mart with an optional data warehouse that I haven't put on this slide. Each layer has its purpose. Each tool owns its own objects. Here is a slide kind of showing from left to right all of our data sources. This represents all of them. So in some environments, you might have one or two as you're just getting started. In others, you might have dozens of sources. We extract and load them. We like to work with both Fivetran and Matillion because there are pros and cons to both. One of the really big things that we love about Fivetran is you can set up. I don't know, one day I was waiting on somebody and we were going to load data with Fivetran, and the engineer forgot to bring the passwords with him to the meeting. So we had to reschedule, and I had a few minutes. So I went and I logged in 12 of Cloud Data's sources, and we use a variety of tools just like that, HubSpot and Zoom and 11 others or 10 others. And I was able to connect those all and have those loading into the raw database in less than an hour. So that if you have the logins and the passwords and the connection information in Fivetran, you load it up, you can set up the connections and forget about it. You come back the next day and the data is in Snowflake. We've heard some really horrific stories about companies who would spend 3 years and $1.5 million trying to get the data into the raw section of a different tool. Just being able to turn it on and have it load into Snowflake. Worst case, if you have huge amounts of data, it might take a day or 2 days, maybe a little longer. Sometimes, depending if you have massive data, we might have to optimize those connections. But in general, it's connect and forget and come back the next day. Then we transform the data and we go into the data warehouse, as I mentioned before, or in one of our application databases. Here I'm showing EDW or an operational data store. This slide is representing, picking up from the last slide, but blowing up what happens in the EDW. We like to, there's a couple of transformation tools we work primarily with, but once you get it into the raw section, we're going to transform that data. These stages, I learned these from my mentor who taught me DBT, and we love the way that works and the flow. And then as we're using Coalesce, we're following a similar stage. I think Coalesce teaches a slightly different naming standard, but it's the same idea. So compute clusters or warehouses, we don't want to mess with them except at startup time and maybe a little tuning over time. But the thing about Snowflake warehouses is that each size up from extra small, medium, large, extra large, we typically don't need larger than extra large, but if we do, we can go up to 6 extra large. Each size is 2 times the prior one, and it costs a multiple of what the first one costs, but usually your code up to a certain scale will run 2 times, 4 times, 8 times, or 16 times faster with the larger warehouses. We build for 2 primary workload types, the load and transform of data and the business intelligence data. And they're slightly different workloads. The load and transform, it's usually a shot of load or transform. And then we can just shut it off and we don't care about the cache generally. But with the business intelligence workload, we want to be able to tune that a little bit to leave it on, to have it auto scale, for instance. We also want to make sure that we have a good separation between development and production. Okay, I wasn't going to do a demo in this session until I reread what we told you we were going to do. What this I'm showing here is there's just, when you start with Snowflake, there is a Snowflake database and nothing else. If we go down and look at users and roles, this is my DBA login and one of my teammates login. If we look at the roles, these are the standard roles that come with Snowflake, and that's about it. I'm not going to share all the code. I just want to share that once we go to run it, we use TerraGrunt to run across multiple modules. We have a foundation module, which is creating the key pairs, and I did not destroy the key pairs just to make it a little bit faster so that it wouldn't take as long to run. But one of the things we set up in TerraGrunt, or what you do in TerraGrunt, is you say, okay, I have to run these modules in a particular order. So it will look to see the order and it will run them accordingly. So I have an alias here, and TGAA stands for TerraGrunt apply and auto approve. And so we'll kick this off and we may go back to the slide deck for a minute. This should run for 1.5 minutes, 2 minutes. One of the things that we sometimes do is we'll also use Terraform, TerraGrunt to manage infrastructure in the AWS cloud. This is running from my Mac here in Denver, and our warehouse or our Snowflake account is in US West 2, which is near Portland, Oregon. And so there's some latency. And if we put everything in a two instance running Linux, we can actually execute this about 20 times faster. But that was a little more complicated than I wanted to do. So what we're doing here, the account module is setting up the basic roles that are going to be needed by everything else. And I'm going to let that run for a minute. And let's see here. We're at 23 after. I'm going to give it another minute or so, and then I'll move on because this is just a little bit probably boring. I'll stop sharing here, and I'm going to go back to my slide deck, and we'll come back and look at this in a little bit. Okay, so the deployment is running, but let's talk about tools while we wait for that to finish running. I've worked with tons of tools over the years. I've hand coded things, I've scripted them, I've used Informatica and I don't know, a whole bunch of other tools that I'm going blank on at the moment. But I wanted to mention our preferred data stack. We've been doing this for 6 years with Snowflake as our primary platform. We love Fivetran and Matillion. They both have pros and cons. Our data catalog is a lightweight data catalog. Dataedo is awesome, and I may do another session on that by itself. For doing the transformation, our favorites are Coalesce or DBT. For business intelligence, we really loved Looker with spectacles. That's not the only tool out there anymore, but Looker got bought by Google, and that just because they're such a big company, it made it a little harder to find the Looker salespeople and to work with them compared to when we used to be a Looker partner and work directly with the Looker team. One thing I want to call out that I keep looking for other tools that have this. Spectacles is an awesome separate application, but what it does is it allows you to set up regression tests and full testing of your Looker environment. So many times we'll make a little mistake in our BI tool. We don't notice it. If you're doing nothing but manual testing, it is either very labor intensive to try to test everything, which makes it very expensive, or we do a light testing and then deploy. And then unfortunately, sometimes if you do that, the end users will find the issues. With Fivetran and Matillion, we're able to ingest in hours instead of months. Again, raw layer, automatic table creation. We focus on the connections, not on ELT or ETL. In order to be super productive, we have to learn the data, especially if you have a new team member, if you're new on a project, if we're starting a new project, we need to be able to learn the source systems and the data that are in the source systems. So what we do is we load our data into Snowflake, into a raw area, and then using Dataedo, we're able to set up an automated data profile of all the data that we've now loaded into Snowflake. You could data profile it in the source system, but you risk slowing down the source system and causing issues with the production system. So we copy the data into Snowflake, we kick off a data profile. The other thing that is super powerful is being able to ingest the metadata from the source system. So we have a client who is a big SQL Server user. They have an ERP, but they've been developing their own code, stored procedures, in addition to the ERP, views and stored procedures that had tons of logic in it. We were able to ingest that into Dataedo, where Dataedo indexes it. And then if our requirements document or the example SQL that this client gives us references an object that was in SQL Server, we can search it in Dataedo, and then it will pull in the views, the stored procedures, the triggers if they happen to have any, and lets us search those. And that is such a huge productivity boost. We can also then set it up to automate the data profiling and the data ingestion so that weekly or some periodicity, we can automatically refresh it because we're developing things there. The source systems are developing things, and then we can automatically keep that up to date. Data profiling in general saves huge amounts of data engineering time. I can't tell you how many hours I've spent 10, 15 years ago having to write little queries myself, select max, select min, select count, average length, what's the length of the column, saves huge amounts of engineering time. It helps us learn the data quickly by revealing what the data actually looks like, the good, the bad, and the ugly. A lot of times we will find there might be 4,000, 5,000 tables in an ERP system. When we data profile them, we'll find a whole bunch of them are empty, or even the ones that are not empty, there will be lots of columns. Perhaps a table has 300 columns in it, and a third or a half or even more sometimes of those columns are empty. That allows us to just remove those from our field of view after that. So we don't need to look at it anymore. Oh, some columns may just have a single value, right? Even though they're not null, a single value contains no data. So when it's obvious noise, we can use code generation to remove those columns out of our field of view. So transformation, a lot of our tools now will come with built-in software development lifecycle, which that is the thing that I found missing for the most of my career, or the first 3/4 of it. We want to develop and transform data to get it into the EDW. Another thing that this point is really important, and it's a big change from the way we used to do it. And I have a slide later that I can show it, but the idea is that we want to load production data into the raw databases, and then we're going to develop our transformations pointing at production raw data. In the old days, we would try to have a development raw database that we were going to transform, but it didn't have the edge cases. It didn't have the full amount of data, and it was really hard to test your transformations unless you had all the data in your development lifecycle. So that's a big change from how we used to do it. Coalesce or DBT will own all the transformation objects. They will create the tables, drop the tables and it could be tables, it can be views, it can be dynamic tables. Using the future-based grants, that really simplifies and adds to the productivity or the efficiency in our whole system, because I can't tell you how many times we used to have to think about doing the grants, or the grants wouldn't get done and it would break something. So we also want to have all of our, and I'm probably going to repeat myself here, but we want everything in version control. Idempotency is a term that I learned probably when I started learning DBT. I'd probably heard it before, but the idea, if you haven't heard of idempotency, is that when a transform is idempotent, we do not care about the current state of the target when we start running our transformation. The easiest way to maybe think about that is that in DBT or Coalesce, we will do a create or replace table. And then the select statement puts everything into the target table. And we don't care what it looks like when we go to migrate from dev to test to prod. That completely changes how we do deployments between dev to test and test to prod. The other thing that in our tools, it allows us to, they're not completely, the test running is automated. We still need to configure tests, but these tools make it really easy to configure tests. The things that we think are absolutely minimum are a unique and not null on the primary key, and then we want to have a test on the foreign keys. That is trivial to set up in DBT and in Coalesce. The other things our tools allow us to do now is column level lineage tracking, which is really powerful, because if you have a column that doesn't look right, you can trace upstream to see where the data came from. So this is the slide I mentioned that I'm trying to highlight the fact that we are developing from production data and only production data. So with Fivetran, we will connect it. We load it into our production Fivetran database, and then our developers will work in the development database, but they'll be using as a source the production database to ingest their data. Then when we migrate to test, the test database is reading from the production database. And then when we migrate to production, it's all reading from production. This is such a huge efficiency gain. I can't give it enough credit. It makes a huge difference. I'm going to take a second now. Let's go back and see how our deployment has gone. And if we look, so here we have, here's all the code that was running. It finished running. Boring just to see that. But now let's go see the state of our Snowflake account. All right. So if we now start looking, we have databases. This is a minimum setup. A lot of times we will end up with a lot more than this, but we have a raw Fivetran database. We have a raw Matillion database. We have an EDW, a history database, and this is the minimum configuration. We also set up sandbox databases for different users. This one just is the finance, but you may have a finance and HR, manufacturing, but that is a database we set up for power users. If we now go check on admin and we look at our users and roles, we've set up service account users for each of the apps that need to have service accounts for running your programs in an automated fashion. And we have all of these roles. And we didn't go into a lot of detail about the roles and the role hierarchy, but the gist of it is that every database has an owner role, a read-only role, and a read-write role. And hypothetically, you might get away with only an owner role and a read-only role. I came from an environment in financial circles, Citigroup, Charles Schwab, Western Union, where Sarbanes-Oxley would apply, and we had to be pretty rigorous about role-based access control. So I just, not even thinking about it, I designed it into our system. If we look at the graph, for anybody that is familiar with, a little more familiar with Snowflake, what we have here now is pretty much everything rolls up to sysadmin, rolls up to account admin, and then we have a prod admin role. Everything else rolls up to all the prod stuff rolls up to the prod admin role, and the dev stuff rolls up to the dev admin role over here. One of the anti-patterns we occasionally see, and we occasionally even see it when a large consulting company has come in and helped the client, is everything is owned by account admin. What that means is that you really have no role-based access control, and every developer has to have the account admin role. Every user who's going to read data has to have the account admin role because everything is owned by account admin, and that is definitely an anti-pattern. Okay. Now, I want to throw this out really quick in case some people can't stay to the end. If you have any questions, want to go into any more detail on any of this stuff, this is my Calendly link. Hopefully it's easy to remember, calendly.com, my first name, last name, all one word. Now I'll spend just a couple of minutes running through. So one of the things I thought about was covering like the big picture program. And then I went back and I reread our description of what we were going to cover. And I saw that I needed to show the demo and talk a little bit more about the Snowflake. But Snowflake is just one part of, and good tools are just one part of your data program and making sure that you're efficient and having a good data program. One huge thing that we need to do is we need to learn about the business. We need to learn about the systems and the data. And that is a non-trivial thing to do. So part of our practice is we will record all of our stakeholder meetings. We'll use large language models to summarize the meetings and put the summaries into our meeting minutes. We will, as we go, we populate the business glossary with new terms. Every time we go into a new client, every company has their own language, and we have to learn that language. And every new employee has to learn that language. So we think it's critical to have a business glossary. Dataedo makes it really easy to manage that and publish it. I mentioned it a little bit later, but logging key decisions is really important. So we want to avoid some knowledge traps. If we don't document our decisions, what can happen is you'll get a new person in. It might even be a really senior person that comes in 2 years into the program, and they have really strong opinions about decisions that were made over the last 2 years, and maybe they want to redo everything. If there's no documentation, they won't understand all the thoughts that went into making those decisions. and they may make decisions that are less than optimal and cost the program a ton of money and a ton of time. So if you've documented your decisions, they may still want to change it, but at least they'll understand what went into that decision before they start changing everything. We think it's really important to record the table and column definitions during development. And if they're not already recorded, some source systems have documentation for the columns, others don't. We want to make sure we're not using too much technical jargon, especially if we're going to have business people review it. We love that Dataedo lets us automate the metadata capture, and we want to share the meeting summaries to the key stakeholders. Couple things really quick on quality and testing. Our tools let us set up some automated tests that will run either every build or periodically. Sometimes it's more expensive. In Snowflake, if you're running the test every single build, it's overkill. So what we've learned to do is to set them up to run intermittently. A couple of productivity accelerators. I'm just going to pound through these really fast because we're about out of time. Zero copy cloning in Snowflake. If you don't know about it, it's amazing. I've seen anti-patterns where people will make a copy of an entire huge table as a backup during their stored procedures and their ETL, and that's super expensive. We can do a zero copy clone in a few milliseconds that gives us a pointer back to the point in time. Time travel lets us roll back to any point in time up to 90 days. Dynamic tables, we can talk more about those at some point if you want, but we're running out of time. This slide is just to talk a little bit about cost, performance, and optimization. We said a little bit about that at the beginning. Auto start, auto stop, multi-cluster warehouses allow our compute to scale quickly up and back down again. All right, I'm going to just kind of go. Productivity patterns, we want to keep good naming conventions. We want to do data profiling, data dictionary. Some of that we've already talked about. And I'll just repeat the productivity flywheel from the beginning. We want to start with Terraform, not clicks or scripts. Buy tools, don't build them. Document for your future self. I like that expression. Test with production data. I think I was going to reword that a little bit, but we want to develop against production data. I'm going to skip this one. And we're done. Questions. So I'm going to figure out how to share less of this slide and see if I can figure out how to look for if people have questions. That's a great question. So the question is, how difficult is it to implement your Snowflake configuration in a Snowflake account that is already in production? So we have needed to do that a couple of times. What we have to check for is that we don't have any name collisions with objects that already exist. And generally, because we have a pretty rigorous naming standard, we don't hit that. And then we have to make a plan to migrate everything that's already in production has to get migrated into the new namespaces. Generally, that's not a big deal. We can sometimes build some what I call a code generator. Basically, one of the very first things that I learned in the 90s when I was on my first database, I had a mentor who came in and tutored me a little bit, and he taught me how to write SQL that writes SQL. And generally, it's not terribly hard. And depending on the complexity of your system, we would develop a plan. Does that answer the question for whoever asked the question? Are there any other questions, or does anybody want to see anything else as we're thinking about this? I'm happy to hang out for a minute in case anybody thinks of a question, or if they just haven't used Zoom in a while and haven't found the button to ask questions. I am also happy to take questions offline. You have my Calendly, so I'm going to go ahead and say that we answered it live. Okay, the next question is, can you elaborate a bit? You mentioned the use of future grants in Snowflake. Can you elaborate a bit on how that future-proofs your deployments? What it does is it removes the labor and the coordination and all of the coding that we might have to do to keep the grants issued appropriately. The future-based grants are actually part of our naming convention strategy. So I didn't go into that in very much detail, but every database that we create, we have three standard roles. So database, and we have a very standard naming pattern, and we have a standard naming pattern for the databases, but every database has an underscore database name underscore owner role. And that is the role that is used to create everything in Snowflake. One of the confusing things when people first start into Snowflake, if they've worked with a ton of other databases in the past, is that Snowflake, everything is owned by a role. And in my experience with all the other databases that I had worked with, things were generally owned by a user in Oracle and SQL Server in just several other databases, right? There would be a user, and it could be a system user, or you could reserve that user as a system user, but it was the user that owned objects. With Snowflake, it's a role that owns objects. We have an owner role, and we say that right in the name. This is the database owner role. We have, and then everything in that database is owned by that role. The future based grants, anything that gets created in primarily if the owner role creates it, so it already owns it and has all privileges. But because we're creating a read-only role and a read-write role, having those grants issued immediately allows us to, and I'll show the way we set things up is the service account user for Fivetran will have the default role will be the prod Fivetran raw DB owner role. So everything that service account user creates is owned by the Fivetran owner role. It grants read only. Let's just think about read only. We won't worry about read write for now. But the future based grants, every object that gets created in here gets granted to the prod Fivetran raw DB read only role. And the read-only role has already been granted to the database roles for dev, test, and prod. So in dev, our database name is dev edw db, and everybody who's working there will use the dev edw db owner role. And that owner role will have been granted read only on the production databases. So now that is how we keep our role-based access control. And there's a word that just left me, but just give the minimum grants available for that. So the read-only role gets granted to the owner role in both dev, test, and in prod. And then in general, our BI service account user will need to read from the production data mart. And so it gets the read only role so that the BI tool can read the data out of the data mart. Now, with the advent of tools that have write back, for instance, Sigma, which we are very impressed with so far, and it may be our next referral partner agreement. But with Sigma, it has the ability to write back, in which case we would have probably a separate database or a separate schema that would have where we can give Sigma the ability to write back into Snowflake. All right. I think that's it. Thank you guys for coming. Thank you. We're going to have a recording for this when it's done. We will start advertising the next webinar in the very near future. Coming up in July, I am doing a webinar with Quest Software. The Irwin product manager and I are going to do they're going to be sponsoring it. So it'll be their webinar, but that's coming in July. Thank you for the questions. I appreciate it.